Hi everyone, welcome back to Graph Theory Visualized. In this chapter, we'll be discussing the concept of subgraphs, so that we can build up to the definition of what a connected graph is. First, let's start with the idea of a subgraph. Guessing from the name, we can assume that this is referring to a smaller graph within a graph. Formally, a subgraph is determined by a subset of vertices of V of G and a subset of edges in E of G. We have various types of subgraphs. Given a subgraph H and a larger graph G, H is called a proper subgraph if both the edge set of H and the vertex set of H are proper subsets of V of G and E of G. Proper meaning the subset isn't equal to the larger set itself. H is called a spanning subgraph if H has all the same vertices as G. I like to think of H as having to span or stretch across the vertices of G. Lastly, we have an induced subgraph, which can be seen as the opposite of a spanning subgraph. This is when the vertex set of H has some vertices of V of G, but all the edges of those vertices selected. In this example, we select vertices V4 and V7. We then have an induced subgraph of G. Some further clarification, given a subset of vertices of G, we need all of the edges that connect to this set of vertices to form the induced subgraph. I like to think of inducing a subgraph given the vertices we want, and then we create the subgraph within those edges. From here, we exclude the edges that don't connect to adjacent vertices of the selected subset of vertices. Building upon the idea of subgraphs, we move on to the idea of UV walks. By the name, you can imagine someone walking across the graph from vertex U to a vertex V. Notationally, this is shown as a sequence of labeled vertices. These walks can have various restrictions. For example, a UV walk that doesn't have repeating vertices is known as a UV path. An analog for edges is known as a UV trail. A UV trail does not allow a repeat of edges. I like to use the analogy with a stone path on a river and a dirt trail to remember the difference. When we walk on stones in a river, we step on separate stones to get across, whereas on a dirt trail, it is one continuous dirt trail. These walks can also form closed loops to each other. A closed trail is called a circuit. Lastly, a circuit that starts and ends on the same vertex is called a cycle. Now that we know what a UV walk is, we can define what a connected graph is. A connected graph is when every two vertices of the graph has a UV path. Therefore, a graph that doesn't have a UV path for some two vertices in the graph is called a disconnected graph. The induced subgraph we showed earlier is an example of a disconnected graph. Note that disconnected graphs can have connected subgraphs. These are known as components of a graph. Now, with the knowledge of subgraphs and the concept of graph connectedness, we can now explore some classes of graphs. We'll explore more of these in the next chapter. Until next time.